Factoring a polynomial. The greatest common factor, or the GCF, of two or more numbers is the largest number that can divide into all the numbers. So it has to divide into all the numbers for it to be a factor, and the greatest common factor is the largest number that divides into all the numbers. One method that you can use to find the greatest common factor is the ladder method. And again, what you do is you take your numbers that you're looking for the greatest common factor, you write them in a line, you put a little L over it, and then you divide out common prime numbers, starting with the smallest. So when you look at 24 and 36 in this example, I'm going to divide out the smallest prime number, and because they're both even, I'm going to divide 2 out. So I divide 2 out and I get 12 and 18, and I put it right underneath. And I'm going to continue this process until they no longer have common factors. And because they're even, I'm going to do 2 again, and I'm going to divide it into 12 and 18, and then I get 6 and 9. The 6 and 9 have a common factor of 3, so I'm going to divide 3 into both 6 and 9, and I get 2 and 3, and 2 and 3 no longer have common factors. So this is the ladder method to find the GCF, and the GCF will be the numbers on the side multiplied together. So in this case, my GCF would be 12. 2 times 2 is 4 times 3 is 12. 12 will divide in evenly into 24 and 36, and they will have no more common factors. Pause and try. So again, you can use the ladder method here, or if you just know it, that's great. I'm dividing out the common factor of 5. I get 9 and 15, and then I divide out the common factor of 3, and I get 3 and 5. They no longer have common factors, so the numbers multiplied on the side will be my GCF. So in this case, my GCF for 45 and 75 is 15. So when we're talking about finding the GCF of variables, and we have an example here of x to the third and x to the fifth, well, we do know that x to the third is x times x times x, and x to the fifth is x times x times x times x times x. And the greatest common factor is the greatest factor that divides in evenly into both. So you see here, they both have the greatest common factor of x to the third, so that would be my GCF. A way of doing this is the GCF, when it comes to variables, will always be the lowest exponent. So the GCF of variables will always be the lowest exponent. And I proved it here that the GCF of x to the third and x to the fifth is x to the third. Pause and try. So the GCF in this case would be the variable with the lowest exponent, which is x or y, z squared. So now when you have a combination of the number and variables, you want to first find the numerical GCF. And when you're looking at the numerical part of the monomials here, we have 10, 15, and 25. So the numerical piece, or the GCF for the numbers, is 5. And then the variable part will be the variable with the lowest exponent, and in this case it would be x to the fourth. And then our GCF for these three terms would be 5x to the fourth, putting it together. Pause and try. So the GCF here is 6m squared. So now factoring out the GCF of a polynomial. When you want to factor out the GCF, you're going to first identify the GCF for the polynomial. Once you identify the GCF, you're going to pull it out and put it next to an open parentheses. So you're going to write the GCF and you're going to have an open parentheses. Then you're going to take that GCF and divide it from every term, placing inside the parentheses separated by the appropriate sign, whether it's a plus or minus. So you're going to take the GCF, you're going to divide it out of the original polynomial, and what is left will go inside the parentheses. So let's see what this looks like. So I'm looking for the GCF for 18 and 60. So I can put that in the ladder method and divide out the prime factor of 2. And then I see it also has a prime factor of 3. And 3 and 10 do not have any common factors. So my GCF of the numerical part will be 6. And then looking at the variable part, it will be the variable with the lowest exponent. So I get 6x. So my GCF here is 6x. I'm writing the 6x and putting an open parentheses. And now what I want to do is I want to divide each term by the GCF, and whatever's left after doing the division, I'll put inside the parentheses. So 18 divided by 6 is 3. X to the third divided by x is going to be x squared. So I put that inside the parentheses. And then I'm dividing the 6x out of the 60x, and I get plus 10. So this is factoring out the GCF. I could remultiply this to see if what I get is what I started with. Now this is where we have the GCF, and we have 3 terms. And we found the GCF of 10x to the 5th, 15x 9, and a minus 25x to the 4th. We found it to be the 5x to the 4th. Now I'm going to factor it out of this polynomial, and I'm going to take that GCF and divide it out of each term. And I'm graying this out because ideally, if you could do it in your head, it would make it a lot less work. So I'm dividing 5x to the 4th into 10x to the 5th, and I get 2x. And then I divide 4x to the 4th into 15x to the 9th, and I get plus 3x to the 5th. And then lastly, 25x to the 4th divided by 5x to the 4th gives me minus 5. And I close the parentheses. Again, you could redistribute this to make sure that you get with what you started. And I want to show you this example because sometimes, or not all the time, do we have a GCF with a variable in it. If each term doesn't have a variable, then the GCF will not have a variable included. So in this case, my GCF is just the numerical part, and I see that my GCF would be 4. 4 divides into 4, 4 divides into 12, and 4 divides into 20. So my GCF is 4, and I'm going to divide it out of each term, and whatever's left goes inside the parentheses. So I end up with 4x squared minus 3x plus 5, and I factored out the GCF. Pause and try. So you see the GCF here is 4x. I divide it out of each term and I get 2x minus 3. Pause and try. My GCF here is simply 2. I divide it out of each term and I get 2b squared minus b, remember no coefficient of 1, minus 3.